Hi everyone, in this video we're gonna solve a problem involving compass bearing. It's just one of the methods of expressing bearing. First of all, let me remind you that bearing represents the direction of motion of an object such as a ship or airplane, or it can also be the direction of a second object at a distance relative to the ship or airplane. Now let's define compass bearing and see how it's different from the true bearing that we learned in the previous video. The compass bearing is measured by starting with either north or south line, so here we have options, and then we use an acute angle to show the direction either east or west from that line. Let's look at the examples to better understand what this all means. This is how compass bearing is given. It has three components. In this example, they are N, 47 degrees, E. N stands for the north and E stands for the east. How do we find the direction based on this bearing? Now, the best way is to start by sketching a compass. Then you're going to take the first component, and it tells you at which line to start. Well, N means that we're going to start at the north vector. Next, 47 degrees is the amount of rotation, as you can see it's acute angle, that we have to perform. And then E stands for east and tells us in which direction. So from the north vector, we can go either in clockwise direction towards east, or we can go in a counterclockwise direction towards west. Well, the last component tells us which one it is. Since it says east, we're going to go clockwise towards east, 47 degrees, like that. And then vector shown in red represents the direction of motion of an object. So object is moving in this direction. And I'll make a note that the last component basically tells you where to rotate. And the middle component is the amount of rotation. Let's practice more. Find bearing of south 50 degrees east. First, sketch a compass. Then we'll look at the first component. It's S, stands for south. So we're going to start at the south line, like that. It's going to go down. Then we're going to rotate 50 degrees. In which direction? Again, we have options, either counterclockwise towards east or clockwise towards west. Well, the last component, E, that stands for east, tells us that we have to rotate towards east, so in counterclockwise direction 50 degrees, in this manner. And let's practice one more time. This time it's bearing of north 73 degrees west. The first component, N, tells us that we need to start at the north vector and rotate 73 degrees in the direction towards west. So that's going to be counterclockwise. Like that. Now let's try to do the application problem involving compass bearing. In this example, it says that a ship leaves port and sails on a bearing south 34 degrees west for 2.5 hours. It then turns and sails on a bearing of north 56 degrees west for 3 hours. If the ship's rate is 18 knots, which is in nautical miles per hour, find the distance that the ship is from port. As always, I'm going to stress out that you need to make a labeled sketch. Without it, chances are very low for solving this problem correctly. So let's read it again and start putting things together on our sketch. So ship leaves port and sails on a bearing south 34 degrees west for 2.5 hours. Let's say the port is this point here. I'll denote it by P. Stands for port. And here's the ship just to help us to visualize the problem. So it says that the ship leaves port and sails on a bearing south 34 degrees west. What is this direction? Well, let's try to figure out. Remember we said that first we start by sketching a compass, like that. Now it says the first component is S for south. So we start with the south vector, the one that goes straight down, this one here. And from this vector, we have to rotate 34 degrees in the direction towards west. So that's going to be clockwise direction, 34 degrees. Like that. So that means that this is going to be direction in which ship sails. I'm going to draw a straight line instead of arrow. And then it says that it sails in this direction for 2.5 hours. And after that, it's going to turn. So let's say it's going to be the turning point. Before we move on, let's see if we can determine this distance. We know that ship sails for 2.5 hours, but how far it sails before it turns? Well, we know that ship's rate is 18 knots. It's 18 nautical miles per hour. Well, and if it sails for 2.5 hours, then how many miles is it going to cover? So to find that, we simply have to take 2.5 and multiply by 18. So time times rate, remember that formula? We're going to find the distance. That's going to be 45 miles. I'm going to put that on my sketch as well. 45 miles. So now I know that 45 miles later, it turns. And what's going to be the new direction? So it turns and sails on bearing of north 56 degrees west for 2 hours. Well, let's figure out the direction. I'm going to repeat the steps by placing the compass. The first component of the bearing is N, which is north. So it means that we're going to start this time with the north vector, the one that goes straight up, this one here. And then we have to rotate 56 degrees in the direction towards west. So that would be counterclockwise direction, 56 degrees. Like that. So that's the direction in which ship is going to sail after it turns. I'm going to place a straight line instead of vector. And since it says that it sails for 3 hours, I made that line a little bit longer than my first line. So basically, that ship is now here, right? And the question is to find the distance that the ship is from port. So that would be the distance from this point to this point, or the length of this segment. So I'm gonna label points. We have this point labeled P already. Let's say this point is gonna be point A, and where ship is right now is point B. And the distance that we need to find, I'm gonna denote by X. What else can I add to my sketch? We can find distance AB. We know that ship sailed for 3 hours from point A to point B. And since the ship's rate is 18 knots, we can calculate this distance AB. Same way we calculated distance for the first part of the journey. So that's going to be 3 hours times 18 knots, or miles per hour, time times rate, equals distance. That is 54 miles. I'll add it to my sketch. 54 miles. Now at this point, I think we transferred everything we were given to the sketch. Let's look at it and try to figure out how to find X. Let's see what kind of triangle we got here. For that, it would be good to identify some angles. Well, if I look at angle A, I can see that part of that angle is 56 degrees. Can I find the other part of this angle? This one over here. This north vector and the south vector represent parallel lines, right? And segment PA is a transversal. So that means that we have two alternate interior angles here that are congruent. Well, this 34-degree angle is congruent to the angle that I just labeled here. So that means that it's also 34 degrees. And now I can easily calculate measure of angle A. It's 56 plus 34, which is 90. So measure of angle A is 56 plus 34, that's 90. So we are looking at the right triangle. That's going to be the right angle here. And that's the good news, because now we can pretty quickly find x in this triangle ABP. What do we know? We know two sides, and if we know two sides of the right triangle, we can always find the third side by using the Pythagorean theorem. Let's identify what kind of sides we're looking at. Well, x is the side opposite of the right angle. It means that x is the hypotenuse. And sides AB and AP are the legs of that right triangle. So I'm going to say by the Pythagorean theorem, I'm going to state it in like a very general way. I'm going to say that leg squared plus leg squared equals hypotenuse squared. And as we already determined, 54 and 45 are the legs of this triangle. So it's 54 squared plus 45 squared. And x is the hypotenuse. So on the right hand side, we're going to have x squared. So from here, 54 squared plus 45 squared equals 4,941. And to find x, we have to square root each side. X represents length of a segment, so it's going to take positive value. So square root of 4,941. That's what we got here, and since we had other distances measured in whole numbers, remember, it was 45 miles, 54 miles. So let's round this result to the nearest mile. So we're going to use only the whole part. Since the first digit after the decimal point is 2, we're going to round down, so it's going to be just 70 miles. Well, approximately 70 miles. And here's the complete answer written in a sentence. The ship is 70 miles from port. As with the previous problems, you see that the actual computational part is very basic and simple. But setting up the problem is the most challenging part of this problem. So take time and be careful when you set up your sketch. And as you can see, it's going to be nearly impossible to finish this problem without making a good, accurate sketch.